In the lessons leading up to this lesson, you learned about 3 types of elements made up of 3 different types of building blocks. We learned about atomic elements, which are made up of unbonded atoms. We learned about molecular elements, which were made of atoms of the same type that were bonded together to make molecules. And then we learned about crystal elements, which were atoms of the same type arranged in a repeating lattice pattern. Could have been individual atoms of the same type that repeated, or molecules made up of atoms of the same type that repeated in a lattice. Those were the 3 types of elements that we learned about. But you know what? This universe would be sort of a boring place if it were just made up of those elements, not the exciting place that we know as God's created universe, made up of millions of different kinds of matter, almost an infinite number of different kinds of matter. And that's because elements aren't the whole story. Those individual types of atoms can combine with different types of atoms, and it gives those types of atoms an entirely new set of properties when different atoms combine. And that's what makes all the new, different, and exciting substances we see in the universe around us. In this lesson, we're going to learn about one type of substance that's formed when different atoms come together. We're going to learn about crystal compounds. First off, though, let's take a look at what makes something a compound. This, again, is a familiar slide that you've seen before. We've already studied all 3 types of elements pictured on the bottom. Notice that all of those elements are made up of the same type of atom. What makes a compound different is it's still a pure substance. It's still just one building block of matter, one type of molecule or one type of crystal, except it's made up of different types of atoms that make up those single building blocks. In this lesson, we're going to take a look at crystal compounds, which is the one at the very top. The potassium sulfate represents crystal compounds. We'll get to potassium sulfate in just a second. First off, let's take a look at what a crystal compound exactly is. Again, you know a compound is a pure substance made up of just one type of building block of matter, but it has to be more than one type of atom. That's what qualifies it as a compound. And a crystal is a repeating pattern of atoms or molecules all bonded together. So if we put these together to make a crystal compound, we're going to see that there's different types of atoms, but they're bonded together in the same repeating lattice pattern. So it's just one building block of matter, just one type of crystal. Here's what this looks like. Potassium sulfate is a crystal compound because it's made up of more than one type of atom. We see potassium atoms, sulfur atoms, and oxygen atoms. But those atoms are arranged in a repeating lattice pattern. We see that the potassium atoms remain single atoms in the lattice, and the sulfur and the oxygen bond together to make sulfate molecules. This is a crystal compound because there's more than one type of atom, and it's bonded in a repeating lattice pattern to make just one building block of matter, a crystal. Another example would be this substance, zinc sulfide, used to make cheap glow-in-the-dark products. Zinc sulfide is a crystal compound because it's made up of more than one type of atom, but you'll notice this is different than potassium sulfate was. The zinc atoms are individual and the sulfur atoms are individual, except those individual atoms are bonded in a crystal lattice. There are no molecules bonded in the crystal lattice, no groups of atoms. It's all single atoms in the lattice. But still, this qualifies as a crystal compound because it's more than one type of atom, and it's bonded together to make just one building block, one type of crystal. Here's another example of a crystal compound. Creatine powder is a substance that some bodybuilders and athletes use during workouts to try to increase the load that their muscles are able to carry and hopefully build muscles faster. Although this substance has not been deemed 100% safe, so it's sort of dangerous to use this. Creatine powder is made up of creatine molecules, which are made up of 3 nitrogens, 4 carbons, 2 oxygens, and 9 hydrogen atoms all bonded together. You'll notice that every molecule of creatine is exactly the same as every other molecule of creatine. So in this case, we have the same type of molecule throughout, but it's a crystal compound because even though it's the same type of molecule, exactly the same atoms bonded the exact same way, those molecules are arranged in a repeating crystal lattice pattern. If you see that crystal lattice in the background, it has to be a crystal substance, and in this case, it's a crystal compound because there's more than one type of atom. Another example of a crystal compound would be this substance that we looked at before, ammonium phosphate. And ammonium phosphate is a crystal compound because it makes up a repeating pattern of 2 different kinds of molecules, phosphate and ammonia, but also this substance has different types of atoms. Phosphorus, oxygen, nitrogen, and the little hydrogen atoms all make up this substance. It's a crystal compound, one building block of matter, different types of atoms. And then finally, calcium sulfate is a substance that is used in plaster of Paris, which is used to make hard casts over broken bones. Calcium sulfate is a crystal compound because it's made up of calcium atoms bonded to sulfate molecules. There's different atoms there, calcium, oxygen, and sulfur, and they're bonded in a repeating lattice pattern all the way throughout. Now, there's something I want you to notice about all of these different substances. Are there any liquids or gases in this mix? There are not, because crystal substances can only form solids. That crystal lattice is holding the atoms and molecules together in a tight way, so all the atoms and molecules can do is vibrate in a fixed place. And if you were to heat any of these up to the point that they melted and turned into a liquid, they would no longer be a crystal compound because the crystal lattice would be broken. So that's what a crystal compound is. More than one type of atom arranged in a repeating pattern because they are bonded in a crystal lattice.